In this video, we'll be talking about the graph of an equation. First, some terminology. We can often express a relationship between two quantities as an equation in two variables. For example, what if we wanted, you could consider the relationship y equals 7 minus 3x. What this says is that for every amount of x, we take 7 and subtract 3 times x from 7 to get whatever our y is. And that represents a mathematical relationship between y and x. We then further say that an ordered pair a comma b is a solution or solution point of an equation in x and y when the substitutions x equal a and y equal b make the equation true. We further go ahead and define the graph of an equation as the set of all points that are solutions of the equation. So as an example of how to use this, let's determine whether the points 2, 13 and the points -1, 3 lie on the graph of y equal 10x minus 7. The way we determine this is we basically plug in the x and y value from the point into the equation and see if it's true. For example, if we wanted to know whether 2, 13 satisfies it, that is, again, remember this is our x value, this is our y value. What we actually have is that we would need 13 to equal 10 times 2 minus 7. Well, we see here that that gives us 13 equals 20 minus 7, and 13 equals 13. I should be good and put question marks. And since that happens, it is a point. So this is on the graph. What about -1, -3? Well, -1, -3, if we plug that in, we get -3, we're asking, is that equal to 10 times -1 minus 7? We see here that that gives -3 equaling -10 minus 7. This side would be -17. This side is still -3, so no. So this is not on the graph. And now it's time for you to try an example. So go ahead and determine whether the points 3, -5 and -2, 26 lie on the graph of y equals 14 minus 6x. On the count of 3, I will reveal the answer. 1, 2, 3. So we see here that plugging in the second point first, I don't know why I did that, I just did. -2, 26, and we get that 26 equals 26. So this point is on the graph of y equal 14 minus 6x. Over here, however, we see that plugging in 3, -5 and to here, we get that -5 equals -4. So this point is not on the graph of y equals 14 minus 6x. Now, with those preliminaries out of the way, we can actually sketch a graph of an equation in 4 easy steps. For our first step, we isolate one of the variables in terms of the other variable if possible. For our second step, we construct a table of values showing several solution points. For our third step, we proceed to plot these points in a rectangular coordinate system. And then finally, for our fourth step, we connect those points with a smooth curve or a line. This method is called the point plotting method. And it's helpful because it helps us actually visualize the equation. That's why sketching the graph of an equation is so useful in general, is that we finally get a visualization of what it looks like. So for example, let's start by trying to sketch the graph of 3x plus y equals 7. So step 1 was to isolate one of the variables in terms of the other. Here it looks really easy to isolate y and write it in terms of 3x. So let's write this as y equals 7 minus 3x by subtracting 3x from both sides. So that was step 1. Step 2 was we pick several values. We pick several values in a table, right? So, for instance, what are some good values to pick? I like to pick values around 0 because it gives me an understanding of what's happening. So let's make our table of values. And so we end up with what? Let's pick -2, -1, 0, 1, and 2, for instance, okay? If we do that, what do we get? We have that -2 plugged in gives 7 minus 3 times -2. 7 minus 3 times -2. That's 7 plus 6, which is 13. If we plug -1 in, we get 7 plus 3, which is 10. We plug 0 in, we get 7 minus 0, which is 7. Plug 1 in, we get 7 minus 3, which is 4. And if we plug 2 in, we get 7 minus 3 times 2, which is 6. So 7 minus 6, which is 1. Step 3 then says, let's plot those points. So, that didn't work very well. Okay. Plotting the points, let's go ahead and set up a graph. So we need to go as high as 13. 1, 2, 3, 4, 5, 6, 7. Down here, we need to go from -2 to 2, so 1, 2. Always try to keep your graphs to scale, otherwise you might end up confusing yourself. Here, we see that -2, 13 is a point. So right there. -1, 10 is a point. It's right there. No, -1, 10. Yeah, sorry. It's right there. Then I see 0, 7. Now we're on the y-axis. 1, 2, 3, 4, 7. Good. And then we have 1, 4. And then we have 2, 1. Connecting those points, and then step 4 says we connect the points together, right? Now here, my scale wasn't quite right because this should be, as we will see in the near future section, this should be a line. Okay, but that's basically how you graph. And now it's time to have you try an example, so go ahead and try sketching the graph of each of the following equations. On the count of 3, I'll reveal the answer. 1, 2, 3. So you see here the graphs of these two lines. To try a more advanced example of this, let's go ahead and try sketching the graph of y equals x squared minus 2. Namely, so again, step 1 was we already have it isolated, which is great. So that's done for us. We now make our table of values, x and y. So here, x, again, let's try -2, -1, 0, 1, and 2. I like those values. And here, let's look at negative. So what happens? We get -2 squared minus 2. That's 4 minus 2, which is 2. -1 squared minus 2. 1 minus 2 is -1. Then we have 0 squared minus 2, which is -2. 1 squared minus 2 is -1 again. And 2 squared minus 2 is again 2. Plotting these, let's go through and draw our graph. We go between -1 and 2. Wow, this works out nice. So 1, 2, 3. 1, 2, 3. 1, 2. 1, 2, 3. So if we plot these points, we have -2, comma 2, -1, comma -1, 0, comma -2, 1, comma -1, and 2, comma 2. So 2, 2. Here, this demonstrates why there's some intuition to this. Here we actually get a parabola. Now it's not at all clear as of now why this is the case, but we will see in later sections why this creates this. But basically, how could you get a better graph? You get a better graph by picking points in between. So for instance, if I was trying like -3 halves, +3 halves, it looks like that's about where it cuts through. It's actually going to be a little bit further over. But basically, the way you could shore up this graph and see it better is to actually pick points in between. So now let's have you work an example. Go ahead and try to graph y equals x squared plus 3 and y equals 1 minus x squared. On the count of 3, I'll reveal the solution. 1, 2, 3. So here we see that again we get two different parabolas. An important thing to note here again is that to make this look better, we would really need to pick more values to get a better feel for this. So please, if you're having trouble kind of understanding and seeing the graph, do not hesitate to pick more values. So in conclusion, the point plotting method is really basic, which makes it easy on the one hand, but it's also not very useful. One, how do we know which points are good ones to pick? I always just pick -2 to 2, but in general, it's not. Those can give you really crazy values. Also, can we ever have enough to tell us about the whole graph? And the answer is no, because even if you pick more points, there's always a chance that maybe something really crazy happens. We just kind of assume that a smooth curve works. So in summary, we actually need a lot more intuition before we can draw really nice graphs. In the meantime, if you would like some more practice at the point plotting method, be sure to see page 19 of the textbook and try problems 1, 2, and 7 through 18. In our next video, we'll get better at graphing by first looking at some intercepts of graphs.